Welcome to The Explainer. Today we're digging into what really separates SpaceX and NASA. And look, it's so much deeper than just private company versus government agency. We're talking about a fundamental clash of philosophies, and it's completely changing our future in space.
This quote right here, it gets to the absolute heart of the SpaceX strategy. The idea that things going wrong isn't a failure of the plan, it's an actual part of the plan. It sounds kind of crazy, right? But stick with me, because this one idea is the key to understanding everything.
So, here's how we're going to break this all down. We'll start with their core mindsets, then see how that turns into action. We'll look at the cold, hard numbers, the results, and finally, we'll pull out a lesson that honestly applies to way more than just building rockets.
Okay, so the real divide between NASA and SpaceX isn't about their budgets or even their ultimate goals. It's about something much more basic. It's about how they believe you actually learn things. It's a battle between planning every detail versus getting real-world feedback.
You know, the whole conflict really comes down to this one big idea that SpaceX basically pulled from the software world: empirical observation. It's a fancy term, but all it means is that real knowledge doesn't come from a theory or a computer simulation. It comes from seeing what actually happens with your own eyes. Everything else is just a guess.
And this slide just lays out the two extremes perfectly. You have NASA's method, build a mountain of paperwork trying to think of every single thing that could possibly go wrong. And then you have SpaceX, which for its unmanned tests basically says, let's just launch it and see what happens, even if what happens is a spectacular fire.
So how do these different ways of thinking actually play out in the real world? Well, they lead to two completely different recipes for how you build a rocket.
So on one hand, you've got the classic NASA approach, which they've perfected over decades. It's all about being meticulous. You think, you plan, you test everything on the ground. Then you replan, all in an effort to squeeze out every tiny bit of risk before that rocket ever sees the light of day. And then you have SpaceX. For their unmanned tests, the goal is just to get into the feedback loop as fast as humanly possible. I mean, why spend years planning for problems you can't even imagine when you can just launch the thing and find out what the real problems are?
Okay, and this is where it starts to sound truly radical. For SpaceX, an explosion like this isn't some terrible disaster. It's a data point, and a really, really valuable one. A single, fiery, real-world test gives them more useful information than years of planning ever could. Here, failure is progress.
All right, so how does this philosophy actually work day to day? It's not just a cool saying on a poster. It shapes the entire way the company operates, from its structure to how it makes decisions. This table just makes it all crystal clear. Look at NASA, a complex hierarchy with lots of committees. Decisions can take a long, long time. Then look at SpaceX. It's flat, it's built for speed, and failures are treated as a core part of learning. It's the difference between a huge one-off project and a platform where everything you build makes the next thing better and faster.
So the crucial point is this: their entire system is designed for one thing, and that's the speed of learning. The faster you can test something, see it fail, learn from it, and iterate, the faster you make real progress. It means that while one organization might still be stuck in a committee meeting, the other is already analyzing data from its latest flight.
Okay, so does all this fail fast stuff actually work? What are the tangible results of these two wildly different philosophies? Well, the numbers, they are absolutely staggering. First up, the price of a single launch. NASA's SLS rocket costs anywhere from $2 to $4 billion per launch. SpaceX's Falcon 9? About $67 million. These numbers aren't just in different leagues, they're in different universes. Next, look at how often they launch. Because SpaceX's whole model is built on reuse and rapid iteration, their launch rate is just off the charts. We're talking over 90 launches in a year, compared to just a handful from NASA. They launch more in a single month than NASA does all year.
And all of this translates directly to the metric that truly matters if you want to open up access to space: the cost to send 1 kilogram into orbit. As you can see, SpaceX is already unbelievably more economical, and they're really just getting started. And this is the holy grail. SpaceX's ultimate goal for Starship is to get the cost to orbit under $100 per kilogram. Now, if they hit that number, that isn't just an improvement, It's a total, complete revolution for humanity's relationship with space.
So what's the big takeaway from all this? This story isn't just about engineering. The core lesson here applies to pretty much everything, far beyond the world of rockets.
This quote right here shows you their ultimate priority. SpaceX understands its most precious resource isn't metal or fuel. It's time. Rockets are things. You can always build another one. But time, the time you could have spent learning, that's gone forever. Every moment spent planning is a moment not spent doing.
This whole approach really teaches us a powerful three-step lesson. 1. Planning feels safe, but a lot of the time it's just an illusion. 2. Real learning, real progress, that only comes from actually taking action. And 3. The key to getting good at anything is the speed of iteration. How fast you can try, learn, and try again.
Ultimately, this whole comparison leaves us with a really powerful question to ask ourselves. In any field, what's the real difference between an expert and a novice? It's not how smart they are or how detailed their plans are, it's the depth of their experience. Experience gained from actually doing the thing. It's knowledge forged in practice, not just in theory.